Okay, that was great. That's never happened before. Michelle, can you do me a favor and bring over that water? I left that with you. All right, so this is called Consequences of an Insightful Algorithm. And the talk is a toolkit for empathetic coding. We're going to be delving into some specific examples of uncritical programming and painful results from doing things in ways that were benignly intended. And in that spirit, I want to start with a content warning, because I'm going to be dealing with a number of examples here that are kind of sensitive topics. Grief, PTSD, depression, miscarriage, fertility, racial profiling, concentration camps, surveillance, sexual history, consent, and assault. And while these aren't the major point of the talk, in about 10 minutes or so, we'll start getting into some examples that deal with those. So you've got a little bit of time to decide if it's not the right moment for you. Algorithms impose consequences on people all the time. We're able to extract remarkably precise insights about an individual, but do we have a right to know what they didn't consent to share, even when they're willingly sharing the data that leads us there? How do we even mitigate against unintended consequences like these? Let's start by just thinking about what is an algorithm. Defined really generically, it's just a step-by-step set of operations for predictably arriving at an outcome. And predictably is really pivotal here. And of course, usually when we're talking about algorithms, we're talking about algorithms of computer science or mathematics, patterns of instructions that are articulated in code or in formulas. But you can also think of algorithms as being something in just ordinary everyday life, patterns of instructions that can be articulated in all sorts of ways, such as a map or a recipe or even a crochet pattern. Deep learning is the new hotness in machine learning right now, and essentially you can loosely define it as algorithms for fast, trainable, artificial neural networks. It's a technology that's been around for quite a while, at least since the 80s, but mostly in kind of theoretical scale and really kind of confined to academia. Just in the past few years, there's been some really big advances in a variety of ways that have made deep learning now realistic for extracting insights out of big data in production deployment. And that's really exciting and opening up a lot of possibilities. In particular, it's an approach to building and training artificial neural networks, and you could think of them as decision-making black boxes. What does that mean? Essentially, we've got some inputs. It's just an array. It might be representing words, concepts, objects, any number of things. Execution is just running a series of functions repeatedly in a series of layers that get more and more precise in their analysis. And then the output are predictions of properties that might be useful for drawing intuitions about future data sets as long as they're similar to that original training data set. And that allows us to do some pretty incredible things, including behavioral prediction, image classification, facial identification, sentiment analysis, and things as extreme as self-driving cars, which Google is already using this stuff for. A number of other companies are as well. So there's a lot of practical applications. And if that's already intriguing you, you can check out later conv.net.js for doing deep learning in the browser. It is definitely not the kind of thing you're going to use for production scale, but it's a great opportunity to explore and experiment. So deep learning relies on an ANN's automated discovery of patterns within that training data set, and it applies those discoveries to draw those intuitions about the future inputs. But there's a caveat here, and that's that every flaw or assumption in that training data set or those original functions is going to have unrecognized influence on the algorithms and the outcomes that they generate. We're going to take a closer look at that in a minute, but first I want to give you a real neat little example of what an ANN is like. This is Mario. It's an ANN that teaches itself how to play Super Mario World. It starts with absolutely no clue whatsoever. All it does is manipulate numbers and notice that sometimes things happen. Over a 24-hour period, it learns movement and play via a purely self-training session in which it engages in those hours of experimentation, each time learning a little bit more about those patterns and identifying them and using them to make predictions for next layer. And speaking of games, let's play one. It looks a little bit like bingo, and it's called Data Mining Fail. Insightful algorithms are full of pitfalls, and by looking at case studies, it's an opportunity for us to explore some of the pitfalls on this particular board. So, are you ready? All right, here we go. In the retail sector, the second trimester of pregnancy is known as the Holy Grail. And the reason is that it is one of the few times in life where consumers' spending habits, product loyalties, brand loyalties are all kind of thrown up in the air. Everything is subject to an opportunity for change. And for retailers, this is an incredible moment, an opportunity to capture a consumer for potentially the rest of their life or even their family. Target, a US department store chain, managed to come up several years ago with a predictive algorithm that was pretty good at identifying customers who were in that second trimester. And so they started sending out ad circulars to those targeted people full of stuff related to pregnancy, babies. A funny thing happened. One day, a man came into the store, and he was really angry. He's yelling at the manager, "How dare you send this to my teenage daughter? Are you trying to tell her to have sex?" Manager, you know, like he's not in charge of this. This is a huge national chain. He apologizes. The guy goes home. He comes back the following day. He says, "I owe you an apology. I talked to my daughter, and it turns out that there were things I did not know, and she is in fact pregnant." So, Target was right, but they were also wrong. What they found were that a lot of women were not okay with having their privacy violated in this way. And the way they described it is some women react badly, which is an interesting moral judgment on that. So they came up with a change in plan. The new one was now ads still go out to the same people, same ads, except they're couched among other ads that seem completely unrelated, so that their perception is that, you know, it's completely random bunch of ads that they just happen to get that have some things that are relevant to their life. And the reason they do this is a quote, "As long as a pregnant woman thinks she hasn't been spied on, as long as we don't spook her, it works." So, algorithms aren't just about the outputs, it's about how we use them and how we abuse them. And this is one of the examples of ways that we can have all the math right and still be wrong. Shutterfly, likewise, was trying to predict some things related to pregnancy. In this case, what they were predicting is recent childbirth. So congratulations on your new bundle of joy. It's time to write some thank you cards to all the people who came to your lovely party. Some of the people who got these said, "Well, I haven't really been pregnant, seeing as how I'm male." And others had different responses. "Thanks, Shutterfly, for the congratulations on my new bundle of joy. I'm horribly infertile, but hey, I'm adopting a kitten, so." "I lost a baby in November who would have been due this week. It was like hitting a wall all over again." Shutterfly's response was that the intent of the email was to target customers who recently had a baby. Well, yes, that's true. That's not an apology. That is a statement that that was what they wanted to do. They failed at it. False positives can be very meaningful. A few months ago, Mark Zuckerberg excitedly announced that he's going to be a father soon. He also wrote on Facebook about a series of miscarriages that he and his wife Priscilla had dealt with as a couple. And this is part of what he had to say. He said, "You feel so hopeful when you learn you're going to have a child. You start imagining who they'll become and dreaming of hopes for their future. You start making plans, and then they're gone. It's a lonely experience." Facebook Year in Review has been around for quite a while. Every year they kind of tweak it. This past year, what they did was much more automated, putting the posts from the past year that they felt were particularly big and important and memorable for you and throwing them back at you at the end of the year to enjoy all over again. What they failed to take into account is that our lives are constantly changing. In the course of a year, many of us have jobs change, relationships change, our life circumstances, all sorts of things. And some of those mean that not every memory stays the joyous one that it once was. Eric Meyer coined the term inadvertent algorithmic cruelty, which he describes as the result of code that works in the overwhelming majority of cases but doesn't take other use cases into account. So why does he get to name it? Well, because he's one of the people it happened to. This is a picture of my daughter, who is dead, who died this year. The Year in Review ad keeps coming up in my feed, rotating through different fun and fabulous backgrounds as if celebrating her death. And there's no obvious way to stop it. Eric calls on us to increase awareness of and consideration of the failure modes, the edge cases, the worst case scenarios. And I hope that we can do some of that today and that you're going to carry it forward to others. And with that in mind, here is my first recommendation for all of us to think about. Be humble. We cannot actually intuit inner state, emotions, private subjectivity. Not yet, anyway. When Fitbit started out, it had a sex tracker. You know, quantified self, let's quantify everything. It counts as exercise, right? There was a wrinkle. The wrinkle was that it defaulted to public. Y'all want a Fitbit now, don't you? All right, so first of all, I appreciate the vigorous effort. Secondly, I also am a certified sex educator, and I'm looking at those 4 hours, and I just don't know whether to congratulate or be concerned. Fitbit users were unwittingly sharing details of their sex life with the whole world. It was on Google. That's because it was set public by default. And this is one of the things that we have to be thinking about, because an algorithm isn't just about crunching numbers. It's also our patterns, our predictable, reproducible ways of action. And in this case, this was a really unthinking decision to not evaluate how different data sets might be differently treated, differently considered, different amounts of privacy in our lives. Just because you want to share with all your friends your competition over how many steps you've taken or how many, runs you've done, doesn't mean that everything in your life is meant to be a public competition as well. This was an algorithm for UX, and it was really a fail here. Let's look at another one. Most of us, use internal op tools. It's kind of mandatory, right? Monitoring, performance tuning, business metrics. There's always something, and in fact, a lot of somethings. Uber's is called God View. And if you're a gamer, you're already suspecting what this implies. Uber did not limit access to admins, and they did not restrict it to operational use alone. Workers could freely identify any passenger and monitor the person's movements. Even drivers were welcome to browse through Uber's customer trip records. Meanwhile, managers felt free to abuse GodView for non-operational purposes, such as stalking celebrities' rides in real time and showing it as party entertainment. And just to give you an idea of how horrifying GodView truly is, here's an actual code excerpt. This is so knowingly inappropriate. I mean, seriously. Autoplay true? Okay, and then of course there's our other choice. Background image, that's pretty telling as well as to what their intent was with this. The research group at dating site OkCupid used to blog all the time about things that they were learning from aggregating their data and looking at trends. And that blog focused on sharing insights into simple ways that OkCupid users could use that dating site well to date better. Uber used to blog about its data too, but there's a kind of critical difference here in that Uber's approach to it was not about improving customers' experience of a ride service. It was about invading people's privacy for the sake of judging and shaming and stalking them. These are not predictable consequences of signing up for an account to take a ride. Google AdWords, there's an interesting study that was done a few years ago at Harvard Essentially what they did was they took two sets of names, one that is strongly correlated with black people and one that's strongly correlated with white people. So for instance, a first name like LaTanya would be something that's highly correlated with black women, and something like Jill would be highly correlated with a white woman. And then what they did was they matched up those first names with the real last names of professors and did some searches on AdWords for those names. And what they found is that a black identifying name was 25% more likely to result in an ad that implied that that person had an arrest record. So for example, ads like these. And I think it's important to note here, AdWords algorithm is focused on predicting what we'll click on. That's it. It's not interested in whether anyone was arrested. That's not its point. The real world isn't important. Its whole job is to figure out what motivates us to click, which ad template we're going to respond to. And based on what it knows about us individually and collectively, what's observed from other users before us, what we're seeing in these ads is our collective bias at work and being reflected back to us and then being reinforced every time it presents it again and we click on it again. This is a feedback loop. Data is generated by people. It's not objective. It's constrained by our tunnel vision. It replicates our flaws. It echoes our preconceptions. Image recognition is hard. And you remember it wasn't so long ago that we had things like this. iPhoto, helpfully detecting faces in baked goods. It's funny, sure. It's a harmless mistake. It's a false positive that's really easy to chuckle at. Some are less funny, such as in this next photo. Flickr classified it as essentially children's playground equipment. For those who are not familiar, that's Auschwitz. This was in May. A month later, Google Photos mistagged this person as an animal. Sorry, that was actually Flickr again, I apologize. It also tagged him as an ape. Google Photos, a month after that, tagged someone as a gorilla. And you'll notice a common theme here, black skin. How does that happen? Well, maybe some of it is, just like those AdWords, our bias being reflected back. There's also other answers, and for one of those, you're going to have to go all the way back to the 1950s. When color film stock was first being developed, created, it was optimized for white skin to get as much detail out of white skin as possible. And for decades, labs were given these. They were called Shirley cards. They were used to calibrate developers to make sure that they were accurately reproducing details and colors. And what this means is that for decades, every film stock was designed to optimize for white skin and to ignore black skin. And black skin, to this day, still has a very hard time getting a nice, accurate, well-exposed photo. When we started moving to digital sensors, the obvious logical thing to do was to replicate the experience that people were already having. If we start having digital sensors that were radically different in their interpretation of light, we would have all been complaining about how terrible and faulty our cameras were, and that would be the end of it. So what we have here is perpetuation of racial animus from the 1950s. And what it means is that we have decades of data sets that are contaminated with noise. And so when we have these kind of misclassifications, it's easy to look at it and just say, mistake, or racism. But it goes deeper than that, and these are hard problems to solve because we always think big data, if we just throw enough data at it, any problem can be corrected. But where are you going to find the data that's an easy corrective for this? Affirm is a rather unusual credit lending company. They focus on lending for certain small consumer purchases and make a rather interesting set of criteria the basis for lending. Essentially, you just provide a few things: name, email, your mobile phone number, birthday, and the last 4 digits of your identification number. And then from there, it starts evaluating behavioral factors even before you've given that much. Things like how long you take to fill in that little form, how much time it takes you to remember stuff. And then if it needs more information, it goes out and looks at your social accounts, including ones like GitHub, which is already starting to replicate privilege in the real world, because only 2% of women, or I'm sorry, only 2% of open source contributors are women. So that means GitHub is inevitably going to be biased towards finding men. And if you're making the criteria for lending being participation on a site like GitHub, automatically it's always going to be biased against a lot of women. But think about also that one about how much time it takes to remember something. Who might need more time? Someone with, say, a cognitive processing disorder, someone who's older. All sorts of biases built into these supposedly objective algorithms. Dear UK researchers, my shopping cart abandonment rate is high because my toddler grabs my Visa card and then runs off screaming, "Mine, mine, mine!" All right, sometimes it's not that we're inattentive because we somehow are a bad credit risk. Sometimes we're inattentive because other things distract us. This is a person whose clock is invisibly ticking and is losing opportunities that are financial as a result of it. A firm analyzes those social media accounts. They're not the only one. There are a number of other companies using similar models. In 2012, in fact, Germany's biggest credit rating agency considered evaluating applicants' Facebook relationships as part of their criteria. And more recently, Facebook filed a patent that pushes even further down that line, making credit decisions about you based on the unrelated credit history of your Facebook friends. Okay, what? So are they unaware that friend doesn't equal Facebook friend? We got to tell Facebook about this. Here's an algorithm with potential to deeply intrude on and alter personal relationships, just to prevent that algorithm from financially shaming and punishing them. This is a huge consequence. Data is not objective. It always has bias. It's inherent at minimum from how it was collected and interpreted. A firm says that its algorithm uses 70,000 factors to reach its conclusions. They say they don't even know what all of them are. All right, so how do we know how many have potential for discriminatory outcomes then? How would anyone know? If they don't know, how is the consumer supposed to do anything about mistakes? Forget about bias, just simple error. Rationales for the algorithm can only be seen from inside that black box. So let's take a look at it. I took a photo from inside a really, really black box. That's what we can see. Making lending decisions inside a black box isn't a radical new business model, it's a regression. What it's disrupting is oversight and regulation. Right now, we're in an arms race. Facebook, Google, Apple, Microsoft, Yahoo, Baidu, IBM, AT&T, Twitter, so many companies right now are making big bets on deep learning. Some are already deploying. And for the moment, quality varies, but we have to remember that deep learning is all about iteratively drawing intuitions at extremely fine-grained levels. And what that means is that they're continuously getting more precise in their correctness, but also more damaging in their wrongness. And that's a dilemma that we have to take seriously as developers, because underlying assumptions influence outcomes and influence consequences. They have underlying assumptions about meaning, about accuracy, about the world in which data has been generated, about how code should assign meaning to data. We care about getting this stuff right. We want to be empathetic. But the question is, how do we flip the paradigm? Well, we can do a few things, like taking some lessons from professional ethicists, because it turns out that's a thing. In fact, it turns out our profession has professional ethicists. Who knew? These are a few that I've adapted from the Association for Computing Machinery and a few other sources. We need to consider decisions' impact, potential impacts on others. For instance, how might a false positive affect someone, like those Shutterfly customers? How might a false negative affect someone? Have we built in recourse for someone to easily get our conclusions corrected when we're wrong about them? We need to be able to project the likelihood of consequences to others and to minimize negative consequences to others. And yes, I keep hammering on to others. We're pretty good at taking care of ourselves. We have to be honest and trustworthy, not just because those are the right things to do, but because we need to be able to lean on it when we make mistakes. We need to be able to buy back trust because we've earned it, because we could say mea culpa without that destroying us. We need to provide others with full disclosure of limitations and call attention to signs of risk of harm to them. And here's a big one. We have to be visionary about countering bias. We have to be visionaries about creating more than one way to counteract it, to counteract biased data, biased analyses, biased impacts. And here's the really big one. We have to be able to anticipate diverse ways to screw up. When teams are charged with defining data collection, use, and analysis, anytime those are less diverse than the intended user base, we're going to keep on failing them, just like this. We have to have decision-making authority in the hands of highly diverse teams. Highly. What does that mean? Culture fit is the antithesis of diversity. It's superficial variations being allowed to exist, as long as their unique perspective can be suppressed, because the point of culture fit is to avoid disruption of groupthink. Unidimensional diversity or variety is not diversity either. Diversity is wildly varied on as many dimensions as possible. Differing origins, differing ages, differing assumptions, differing experiences, until you get to a point where there's no such thing as a majority. You can't find it. We need to cultivate informed consent, and what that means is we ask for permission with the default being no, and we explain the consequences of a yes. We focus on the many people who eagerly want to share themselves and who are enthusiastic about giving consent to be known more and who want to be served better by that. And we have to audit outcomes constantly. And the reason is going back to that black box. If we can't be sure what's happening inside of it, then we need to be able to look at the outcomes. This is used a lot in checking for housing discrimination and job discrimination. So you put in two inputs that are exactly the same on every criteria but one. One that should not have any bias introduced. And if the outcome on those differs at all, then you know you've got a problem with the algorithm. So this is something we constantly have to be looking for. For instance, when Google Photos made that mistake with classifying people as gorillas, as soon as they saw that problem on Flickr a month earlier, they should have been doing auditing. Do we have the same problem? And why? Because photo of a big black box. And that's why we also have to commit to data transparency and algorithmic transparency. And I do mean both because, you know, I recognize that these are hard decisions to have internally. They truly are. But I also think that, you know, it wasn't that long ago that we were fighting for the legitimacy of open source in our professional toolkit. We pushed back, we were right, we're professionals. We won because we know what we're doing and we made a good argument. We know that transparency is crucial for drawing insights that are genuine and useful. So argue for increasing transparency because it's for a better product. Cleaner features, fewer bugs, stronger tests, happier users, public trust. That's the argument. Because we want to build stuff that matters. We're hired for more than just to write code. We're hired as professionals who apply expertise and judgment about how to solve problems. That's who we really are. We're not code monkeys. We're people who think about how to solve problems. Our role is to be opinionated about how to make code serve the problem space well. We can advocate. When we're asked to write code that presumes to intuit people's internal life and act on those assumptions, as professionals, we have to be people's proxies. We have to be their advocates. Say no on their behalf to using their data in ways that they have not enthusiastically and knowingly consented to. Say no to uncritically reproducing systems that were biased to begin with. Say no to writing code that imposes unauthorized consequences onto their lives. In short, refuse to play along. Thank you.